Hi there, Mr. Sutton here, bringing you the Algebra 2 Honors 4-6 Part 2 homework solutions on Fundamental Theorem of Algebra. In this one, we are going to be building some polynomials and also using Descartes' rule of signs. For the next few problems, we're going to be writing a polynomial based on the roots that they're giving us. So let's start with this one by creating some factors for these three roots. So we're going to have x minus each of the roots. So we have x minus negative 2, which is x plus 2, and then we have x minus 3 and x minus 6. All that remains now to get this in standard form is just to multiply these all out. So I'll start that process by multiplying these first two parentheses together. So that'll give us an x squared, and then we'll have a negative 3x and a 2x, which adds up to a negative x in the middle, and then 2 times negative 3 is negative 6. All right, now we're going to distribute everything in this first big parentheses to this second parentheses. So we have x squared times x minus 6 minus x times x minus 6 minus 6 times x minus 6. Going back and distributing in each of these situations here, we have x cubed minus 6x squared, and then this will be a minus 1x squared, and then negative x and negative 6 is plus 6x. This will be minus 6 and plus 36. Combining like terms, we have an x cubed that's got no one else to combine with, so it just stays the way it is. And negative 6x squared minus x squared gives us negative 7x squared. 6x minus 6x actually just cancels out. All that's left then is this plus 36. To build a polynomial using these roots, we're going to put them in factors first. So we're going to have x minus negative 2, or x plus 2. We're going to have x minus parentheses 1 plus radical 7. And because of the irrational conjugates theorem, if we have a 1 plus radical 7, that means that one of the roots that they're not showing us is 1 minus radical 7. So we're going to do x minus parentheses 1 minus radical 7. And now we're going to multiply all this stuff together. Before I do that, though, I'm going to distribute these negatives in these second parentheses and then regroup things. So I'm going to do a minus 1 minus radical 7, and I'm going to put the x and the minus 1 together in their own parentheses. I'll do the same thing over here. This will be x minus 1 in a parentheses, and then we'll have a plus radical 7 to go with that as well. So I just distributed and regrouped. Now I can treat these last two parentheses as kind of like an a minus b, a plus b situation, and just square the two things in each parentheses and put a subtraction between them. So we're going to have x minus 1 quantity squared, and this x plus 2 just keeps coming along for the ride here. And then I'm going to square the radical 7, and we'll put a minus between those. So this is, again, a squared minus b squared kind of reasoning. Next, let me expand this x minus 1 squared. So that's going to be x squared. And then if I multiply these and double it, that's going to be negative 2x. And then squaring negative 1 gives me positive 1, with that negative 7 along for the ride. So this is going to add up to negative 6 over there, just to simplify a little more before I distribute. But now distribute I must. Everything in the first parentheses to this whole second parentheses. So we have x times all of this stuff plus 2 times all of this stuff. Distributing in each of those individual ones, we have x cubed minus 2x squared, and this will be minus 6x. Distributing the 2 gives us a 2x squared minus 4x minus 12. And now combining like terms, we have an x cubed. The negative 2x squared and positive 2x squared cancel out. Negative 6x minus 4x is negative 10x, and this minus 12 is still there. To make a polynomial out of these roots, let me first create some factors for my roots. So I'll have x minus 3 and x minus parentheses 4 plus I. And because of the complex conjugates theorem, I know that if 4 plus I is one of my roots, then 4 minus I must also be one of my roots. So I'm going to write x minus parentheses 4 minus I. Now let me distribute and regroup some things in these two parentheses here just to clean it up a little. So this will be x minus 4, and that'll go in its own parentheses, and then I'll have a minus I. So I distributed and regrouped things there. And then over here we'll have an x minus 4 in a parentheses again, just like this one. And then we'll have a plus I to go with that. For these second and third parentheses, we basically have a minus b and a plus b. So I can turn that into an a squared minus b squared structure. So basically just squaring each of these things and sticking a minus between them. That's kind of why we did this. So this x minus 3 is still there. We have x minus 4 quantity squared. And then we have to square the I, and that'll be subtraction. Let's expand things a little bit and clean up that second parentheses. So we have x squared, and then multiplying these together, that's going to be negative 4x, and then I have to double that for negative 8x. And then 4 squared is going to give me 16. I squared is really negative 1, so negative negative 1 gives me a plus 1 there. And it seems kind of silly, but I'll do it just so I don't have to worry about multiplying by 4 things. Let's combine the 16 and the 1 to get a 17. And now we're ready to distribute everything in the first parentheses to everything in the second. So doing that, we've got x times all of that second parentheses minus 3 times the whole second parentheses. Distributing the x, that's going to give us x cubed minus 8x squared plus 17x. Distributing the negative 3 gives us negative 3x squared plus 24x, and then this will be minus, let's see here, 51, I believe. Yep. Okay. So combining like terms, we have x cubed. Negative 8x squared minus 3x squared is negative 11x squared. 17 and 21 gives us 41x. And then finally we have the negative 51. On the next couple problems, they want us to determine the possible numbers of positive real zeros, negative real zeros, and imaginary zeros for the function. So let's start by getting the total zeros. Since this is 4th degree, we know we have 4 total zeros, so that's a good starting place. And then to get the number of positive real zeros, I just have to look for the number of sign changes in the original function g of x. So we're going positive to negative, that's one sign change. Negative to negative is not a sign change, so there's just one sign change for g of x. That means we have exactly one positive real root. Normally it would be the number of sign changes minus whatever even number you like, but 1 is as small as it's going to get. You couldn't subtract anything from that anyway. So now to get the negative real zeros, we're going to figure out what g of negative x is by plugging negative x into all those x's. So negative x to the 4th is still x to the 4th. Negative x squared is still x squared, and we're still subtracting that. And then that minus 6 hasn't changed. So this function actually is identical to g of x, which means that it again has only one sign change. This means now that g of x has exactly one negative real root. So let's create a table with this one possibility here. We have 4 total. We've seen that the only possibility is that we have one positive real root and one negative real root. Since that's 2 real roots, that means that since we had 4 total, 2 of those then must be imaginary, 4 minus 2. We're going to determine the numbers and types of roots for this g of x function now. Let's start with the total zeros. Since this is 5th degree, we have 5 total zeros. And to find the positive real zeros, we're going to look at the sign changes in g of x. So we go from positive to negative, there's 1. Negative to positive gives us 2, and positive to negative gives us a 3rd sign change. 3 sign changes means we have either 3 positive zeros or 3 minus an even number, so 3 minus 2 would be 1 positive real roots. So 3 or 1, those are the 2 possibilities. Now let's figure out what g of negative x looks like to figure out the number of negative real zeros. So g of negative x just means plugging negative x in for all these x's here. If I do that, this first term now becomes negative x to the 5th. This next one is negative 3 times negative x cubed, so positive 3x cubed. And then this is negative 8x, and the minus 10 is still there. So we're going from negative to positive, that's one sign change. Positive to negative gives us another, and that's it, negative to negative doesn't count. So we have two sign changes. That means I either have two negative real roots or 0. 2 minus an even number, the only even number here being 2. So let's make a table now with all the possibilities. And we have 5 total for all of these rows here. So for my first possibility, I've got 3 positive reals and 2 negative reals. That's a total of 5, which leaves no leftover for the imaginary, so 0 imaginaries if I have this situation. Now we could also look at 3 reals and 0 negative real roots. And when I say 3 reals, I meant 3 positive reals, this row, this column here. If I've got 3 real numbers total, that means 5 minus 3 is going to give us 2 imaginary roots to go with that. Now the next possibility, if we have 1 positive real root and 2 negatives, that's a total of 3. Subtract that from 5 and we see that there's room for 2 imaginary roots there. And then our last option is only 1 positive real root and only, 0 negative real roots. If we've only got 1 real root total, then 5 minus 1 leaves us with 4 imaginary roots in that situation.